Good afternoon, Professor. Hello and welcome. So we are Group 3. Today we'll be presenting our project on database connectivity and XML activity as part of Module 6 assignment. This project was collaborative effort to understand and explain the integration of XML with standard database interfaces in the web-based systems. So let's get started. So the introduction to the project is in this project we're going to explain how commonly used database connectivity interfaces like ODBC, JDBC, and Ado.NET work in real-world systems. So these interfaces form the backbone of how applications communicate with databases. We'll also discuss XML, a widely used data format that allows structured data exchange across many platforms. Finally, we'll show how XML and these database interfaces come together to support modern web development workflows. Moving on. So we have the database connectivity interfaces. These are essential software tools that can act as translators between application and databases. They make it possible for an application to send commands to the database and receive them back. These include ODBC, which works across multiple programming languages, JDBC, which is specific to Java, and Ado.NET is used in Microsoft's systems, ecosystems, and all of these three enable common operations like creating, reading, updating, and deleting records. And these are collectively known as root operations. And so, just an introduction to these. ODBC stands for Open Database Connectivity. It provides universal interface that can interact with various databases, and it is regardless of the programming language. JDBC stands for Java Database Connectivity. It is specific to Java and allows Java applications to run SQL queries. Ado.NET is designed for the .NET platform and is optimized for interacting with both relational databases as well as XML data. Each of these interfaces simplifies the task of the data access in its respective environment. So that's about from me. I am Anirudh. So the next few slides will be explained by my group member, uh, Raja.
Okay. Hello, Professor. Let's start with the next slide. So the role of application and database communication. These connectivity interfaces play a crucial role by acting as an intermediate between the user interface UA and the backend database. When a user interacts with an application, the application generates SQL command and SQL that command these are sent to the database through the interfaces. So the database processes the commands, whichever commands we send, and it will send back the results back. This back and forth process ensures platform and language independence, particularly in the case of ODBC, which is uh, versatile. Okay, the benefits and challenges. Using database connectivity interfaces has several benefits. They provide an abstraction layer that hides complex database operations, uh, you know, which made the which makes the code simpler. They also promote code reusability and help enforce consistent data access patterns. However, there are challenges too. Initial configuration can be time consuming, and some systems may face compatibility issues. Uh, in high traffic scenarios, performance can also be become a bottleneck. Yes. Coming to next slide. This is definition XML definition and purpose. XML stands for the extensible markup language. It is flexible format used to represent the structured data. Unlike HTML, uh, it has the predefined tags, but XML lets the user define their own tags, making it suitable uh, for custom data structures. Its primary purpose is to allow different systems to exchange data in consistent, readable format. Uh, this makes XML extremely valuable for applications that need to share information across the platforms and systems. Now, coming to the advantages of XML in web applications, uh, it has several advantages in a web applications. It's both human readable and machine readable. Uh, it will simplify debugging and automation. The hierarchical structure of XML, it makes perfect for representing nested data structures like customer profiles or order details, etc. And XML can be transformed easily using XSLT and is supported across nearly all programming environments, making it ideal for APIs mainly, configuration files, and data storage. The next From the next slides, my friend will continue the next slides.
Hello everyone. In this slide, we're going to discuss about the XML integration with the database connectivity. Today's databases support XML as a native data type. This means we can store and retrieve XML directly in database fields. Application can use interfaces like ODBC and JDBC to read or write this XML data as a part of the SQL queries. XML data can also be used in configuration files or passed through web services, enabling flexible data exchange in distributed system. Next slide, we can discuss about the example for the XML in SQL with JDBC. Let's take a closer look at how JDBC interacts with XML in database. A Java application can run with a SQL query to extract specific parts of an XML document stored in a table. For example, we might want to extract a customer name from XML column using XPath expression. This integration allows developers to manipulate complex data formats without leaving the database context. Next, another example for the ODBC interaction with the XML. Similarly, applications that we use ODBC can update or retrieve XML data stored in databases. Imagine a situation where a configuration file stored in XML format is read by reporting application. The application can use ODBC to connect to the database, read the XML file, and update values like URLs or service names as needed. This process allows flexible and dynamic configuration management. Next, coming with in this slide, we discuss about the real world use cases. There are many real world scenarios where XML is used in combination with database connectivity interfaces. For example, enterprise application often store the connection settings in XML configuration files. Web services, particularly SOAP-based services, use XML for the data exchange. Additionally, many reporting systems generate output in XML so that it can be transformed into HTML, PDF, or the other formats as needed. The next slide will be discussed by my colleague. Thank you.
Hello, my name is Vishal Tatikaila. So now I'm continuing with the next topic, that is future trends and challenges. Although XML remains widely used, especially in enterprise environments, newer technologies like JSON are becoming more popular due to their simplicity and lower processing requirements. Many modern APIs now prefer JSON, especially in RESTful designs. However, XML still has a place in configuration and legacy systems. The main challenge moving forward will be performance. XML parsing can be resource intensive, and not all modern frameworks support it equally well. Now coming to the conclusion, to summarize, database connectivity interface such as ODBC, JDBC, and ADO.NET are essential tools that help applications interact with databases and in a structured and standardized way. XML complements these interfaces by enabling structured data storage and transfer. Despite evolving trends, the integration of XML with these interfaces continues to support flexible, scalable, and reliable application development. This final slide lists all the scholarly references we used to prepare our presentation. They have been cited throughout our slides and follow APA formatting guidelines. Thank you for your attention and for watching our presentation. Thank you.